Legacy .NET Framework to .NET August 9th, complete migration checklist. So, .NET application modernization. It's something a lot of people ask about, and today we're going to walk through it step by step. Let's talk about why .NET application modernization can end #39. Wait. The gap between .NET Framework and .NET 8.9 is not purely about new language features. It is about infrastructure. .NET Framework runs only on Windows. .NET 8 and .NET 9 run on Linux containers, which means Azure Kubernetes Service, lower compute costs, and CI/CD pipelines that match the rest of the industry. If your team is actively hiring mid-career developers, many of them have never shipped a production .NET Framework application. They know .NET 6 and above. Microsoft benchmarks document .NET 8 handling HTTP workloads significantly faster than .NET Framework 4.8 under comparable conditions. For database-heavy enterprise applications, the improvements in Entity Framework Core 8, including compiled queries and improved batch operations, reduce round-trip latency in measurable ways. Teams migrating payroll engines, insurance claims processors, and order management systems consistently report a 30 to 50% reduction in peak CPU usage after moving to .NET 8. These are not lab numbers. They show up in production dashboards within weeks of cutover. Microsoft's official .NET Lifecycle Policy confirms that .NET Framework 4.8 is the final version and will only receive security and reliability fixes, with no new features. The risk is not that your app stops working tomorrow. The risk is that your dependency on Windows-only infrastructure grows while the rest of your organization moves toward cloud-native patterns, and your ability to recruit developers familiar with the stack shrinks every year. Moving on to, should you modernize your .NET Framework app or rewrite it? The honest answer is that it depends on the codebase, not the technology. Teams that choose a full rewrite typically underestimate the timeline by 40 to 60% and lose accumulated knowledge about edge cases that took years to surface. Teams that choose incremental modernization often underestimate the effort required to untangle shared state, WCF dependencies, and the Windows-only APIs that .NET Framework quietly permitted. The practical decision rule: if the core business logic is sound but the infrastructure is the constraint, modernize incrementally. If the business logic itself is undocumented, incorrect, or tightly coupled to a UI that no longer serves users, a targeted rewrite may be faster over a 24-month horizon. Incremental modernization works best when the application has identifiable module boundaries, even if those modules are not formally separated. It also works when business logic lives in service classes rather than scattered across global .asax or code behind files, when the team has test coverage for at least the critical processing paths, and when the business can absorb 6 to 18 months of parallel track development without requiring a hard cutover date. Let's talk about now the complete migration checklist, phase by phase. In our experience with .NET 9 migration and .NET 8 upgrades, the engagements that stay on schedule follow a consistent sequence. The ones that run over budget typically skip or compress the assessment phase, or they discover WCF dependencies mid-migration that should have been flagged in week 1. Before writing a single line of migrated code, complete these 6 steps. Choose between .NET 8 and .NET 9. For most enterprise applications, .NET 8 is the safer choice because the ecosystem is well established and you get a full 3-year support window. Our .NET 9 migration guide, new features, breaking changes, and safe upgrade path covers the specific breaking changes if you are deciding between the 2 versions. Next up, moving on to how to choose the right modernization pattern. .NET application modernization is not a single approach. The right pattern depends on how tightly coupled your current architecture is and how much business disruption the organization can absorb during the transition. Getting this decision wrong is the most expensive mistake teams make, because reversing a pattern choice mid-project is nearly impossible without extending the timeline significantly. The Strangler Fig pattern is an incremental modernization approach where new functionality is built on the modern platform while the legacy system continues running, with traffic gradually routed to the new system until the legacy application can be decommissioned entirely. Legacy .NET Framework modernization uses the Strangler Fig pattern to incrementally replace components without a full rewrite or service interruption, making it the safest path for systems that cannot tolerate downtime. For .NET migration, this means a reverse proxy routes some requests to the new .NET August 9th service and others to the existing .NET Framework app. New features are built exclusively in the modern stack. Legacy endpoints are migrated one at a time, tested, and validated before the next endpoint moves. The old application is decommissioned module by module, not all at once. Let's talk about moving on to front-end decisions, Blazor, React, and what enterprises actually choose. Front-end modernization runs alongside back-end migration, and this decision carries more weight than most architecture reviews acknowledge. Our detailed breakdown of Blazor versus React for enterprise apps, when each one wins, covers this thoroughly. Here is the decision framework specifically for teams in the middle of a migration. Blazor server renders UI on the server with SignalR, keeping all C# business logic on the server and sending only UI updates to the browser. Blazor WebAssembly runs C# directly in the browser via WebAssembly, enabling offline use and reducing server-side load. For enterprise apps where you control the network, Blazor server is usually the faster path. Blazor WASM makes more sense when the app needs offline capability or when server-side connection overhead becomes a concern at scale. The practical advantage of Blazor development services for .NET teams: your C# developers can build fully interactive UIs without learning a JavaScript framework. Teams with strong C# expertise and limited dedicated front-end resources typically cut UI development time by 25 to 35% compared to adopting React from scratch. Moving on to .NET microservices and API architecture after migration. For larger systems, .NET 9 migration is also the natural moment to evaluate whether a monolith still fits the scaling requirements. Not every application should become microservices. Some monoliths are perfectly appropriate for the team size and traffic patterns involved. But some legacy .NET Framework apps are constrained by their monolithic structure in ways that only become obvious once the runtime constraint is removed. Our .NET Microservices Consulting, Architecture Patterns and Implementation Guide covers decomposition strategy in depth. The short version: decompose by business domain using bounded contexts, not by technical layer. The most common mistake is creating a data service, a UI service, and a logic service, which replicates the monolith's coupling across a network boundary without gaining any of the independence that microservices are supposed to provide. A logistics order management system, for example, typically decomposes into 4 bounded contexts. Now, what slows down legacy app modernization projects? Legacy app modernization projects run over time for predictable, well-documented reasons. None of them are surprising in hindsight. All of them are avoidable with the assessment work described in Phase 1, done thoroughly before the migration timeline is locked. The most common schedule blockers we see across .NET modernization engagements. Mapping every dependency in Phase 1 prevents mid-migration surprises. Discovering a WCF service reference 6 weeks into a migration is a 4 to 8 week unplanned delay on a project that was already scoped without it. Now, let's talk about conclusion. .NET application modernization does not have to be a multi-year slog or a high-risk big bang cutover. The teams that complete it on schedule treat it as a sequence of small, testable increments: thorough assessment first, compatibility testing second, and module-by-module migration with feature flags and parallel deployment. Start with the assessment checklist. Choose your migration pattern based on the codebase's actual structure. Make front-end decisions based on team skills and application requirements, not what sounds most modern. Handle the hard dependencies, WCF, Windows Workflow Foundation, and legacy reporting, early rather than discovering them mid-project. Build governance checkpoints into every phase, especially in regulated industries. If you are evaluating what a full modernization engagement looks like from scoping through production deployment, our enterprise application development, architecture, tech stack, and timeline guide walks through what a well-run enterprise development engagement should include. Q Services works with mid-market and enterprise teams in healthcare, banking, logistics, and SaaS on exactly this kind of .NET application modernization work. Reach out to start with a no-obligation assessment of your current .NET Framework application.